we're talking about sequences and series and how we get through our sequences and series and what are we going to learn in this section. We're starting our chapter 12, which is on sequences and series. We're going to start with the arithmetic sequence and series. Hopefully we're going to understand the difference between a sequence and a series. We're going to find the nth term. We'll talk about what the nth term of an arithmetic sequence is. We'll find the mean of an arithmetic sequence, and we'll learn how to correctly pronounce the word arithmetic. A lot of people say arithmetic. Not quite the same thing. So we start with the problem here. We start with you visit the Grand Canyon and you drop a penny off the edge of a cliff. The distance the penny will fall is 16 feet in the first second and 48 feet in just that second. So it's not 48 feet total by the second, but 48 feet in the second, 80 feet in the third second, and so on in an arithmetic sequence. What is the total distance the object will fall in 6 seconds? Okay, so we're talking about the total distance this object will fall. Go ahead and you could pause, I'd say pause the video right now and see if you can kind of work it out on your own. And I'm going to show you then, hopefully you can come back, and I'll show you what a student showed. This was a student work of how they solved it. And they said, okay, if the first was 16, and they said you really add 32 each time. So each time the student figured out that you're adding 32 to get to the next, how much is in the next second. But then if you realize the question, a lot of people miss this at first, the question is, what is the total distance? And so the emphasis was on this total distance. Well, that total distance shows that my answer here is actually 576 feet that we were working with here. And let me then qualify this and kind of show you a little bit of what we're talking about today. What this is very nice. It kind of shows us what we're talking about. Like right here, this part of the data, the 16, 48, 80, 112, 144, and 176 is a sequence. Okay? This answer here of 576, is a series. A series is the sum of a sequence. Sum of a sequence. A sequence is a set of numbers that goes up by the same value each time. In this case, goes up by 32. All right, let's go through another problem. And we're going to talk about kind of how we can look at series and sequences. So the next problem here says the sum of the interior angles of a triangle is 180 degrees. Of a quadrilateral, which is 4-sided, is 360 degrees. Of a pentagon, which has 5 sides, is 540. Assuming this pattern continues, find the sum of the interior angles of a dodecagon, a 12-sided figure. Again, I'm going to have you pause and try to figure this out. So here's what I have for a solution for this. If the 3 is 180 and the 4-sided is 360, looks like each time we're adding 180 degrees. When you add another side, you add 180 degrees. Each time we're adding 180. And I didn't show how we did all of them. It got it kind of tedious. And then we get to 12 and we have 1800. Okay? It does get tedious sometimes, and so I asked my students to see if they could come up with a rule, and we had students kind of work out what could the rule be for this. So the next question is, what is the rule? Go ahead and pause it and see if you can come up with a rule. What we came up with was the rule, you take the number of sides and subtract 2 and then multiply by 180, and that would give you the sum of your angles. So the sum of the angles would equal the number of sides, subtract 2 from that, and multiply it by 180. So at 3 it was 1 times 180. At 4 it was 2 times 180. At 5 it was 3 times 180. At 6 it's 4 times 187. It's 5 times 180. So at 10 we did, or at 12, we did 10 times 180. When we were looking here at the 12th, this 12 sides, all right, on a technicality was, for this list, would actually have been the 10th term. So this is actually the 10th term in my list, all right? We could also say, well, I choose to say that 2 and 1 and 0 is not really in here. So technically you could say it's really the 13th term, or you could say it's the 12th term. I understand why you would say it's the 12th term. But a lot of times we'll say we're looking for the nth term sorry, I got to spell right, of a sequence, all right, and we just have a sequence here, not a series, because we weren't ever asked to add them all together. And the nth just means how many we've worked with, all right. So I think I'd be okay with calling this, because our n is going to be the 12th term. All right, so it's kind of the n can change depending on what's your starting value, but I would call this the 12th term. I think that would fit our needs very easily here. Here we have another one. We have a trainer telling you that your jogging program is to come back after knee surgery kind of slowly. During the first week, we say, okay, every day do 12 minutes that week. In the second week, you add 6 minutes per day. So in the second week, it would be 18 minutes, but each day of that week, it's 18 minutes. In the third day, it would be, well, 18 plus 6 again, because then it's okay to increase by 6. So 18 plus 6 would be 24, and then you can kind of do weeks and go on plus this. And it says, how long before you are up to jogging 60 minutes per day? I'm actually not going to give you the answer to this one, so you can go ahead and pause it, try to work it out. I'm hoping it will be in another video, or we'll discuss it in class, so you can discuss it in class. It won't be in this set. Here's another one that's a good problem, and I'm not going to give you the answer right now, but you can feel free to pause it and go through and try to figure out the answer, but I'm not going to go over it right now. All right, so we're going to be looking a lot at patterns, and we're going to be saying, what is a pattern? So we had a pattern that we had to figure out before. Here, what's our pattern when we're looking here? Well, hopefully you'll see quickly our pattern is that each time we're adding 3 as we progress, okay? When we have what's called an arithmetic series, it means that we have something that's being added to each term of our series. Okay, so our terms would be the -2, the 1, the 4, the 7, the 10, and so on. And what we're adding is the 3. So in this particular problem, our D, in other words, the difference each time between each term, is 3. So in arithmetic series, it's going to be a big thing to say, what are the differences? Now here it'll say, what are the next 4 terms in this series? So you have to figure out, what's that difference? What am I adding each time? Well, a trick, all right, or a plan might be a better way to find our difference, all right, to find what we're doing, is to take the second number, second term, and subtract the first term. All right, now that word difference kind of makes sense. Well, the second term here minus the first term is -2 minus a -6. Well, if I change the negatives into positives here, I really have -2 plus a +6, which gives me a +4. Let's see, does that work? Are we really adding 4 each time? Yep, it really does work for each of these problems. So now my problem is going to be, how can I keep adding 4 more times? So the next 4 problems here would be 2 plus 4 are 6, 6 plus 4 are 10, 10 plus 4 are 14, and 14 plus 4 or 18. So our answer here is 6, 10, 14, 18. Our D, or our difference each time, we had to first calculate, and that was 4. So in arithmetic sequences, we have a list of numbers, all right, and this is just representing individual numbers here, which the patterns are adding have a common difference, okay? Then we have this thing called a recursive formula, and when we're trying to find the nth term, let's say, we had a dodecagon, we were finding 12. What if we had to find a 25-sided figure? It would take forever to just put it out in a list. So we have found that it really does help to use this recursive formula. What recursive means is we use the previous terms to find the next one. So the next term is the current term plus the difference, okay? So when we had, let's just go back to our original problem, and we were dealing with how far it fell. So I think we started at 16 and 48, and we were adding 32 each time. So wherever we were, whether it be 16, 48, or 80, we could always say, okay, we just have to add that difference each time, and we kind of figured out it had to be 32 each time. So wherever we are now, the next value, you just have to add 32, excuse me, to the value you are at now. And it's going to give you the next value that you're going to be at. So in this formula, let me show you this again. I'm going to kind of erase my discussion here, sorry. So in this formula, let's talk about what everything means. We've already hopefully got that this is the difference between terms, This a to the n minus 1 is the previous term. One right before, the previous term. And the a sub n is the term we're looking for. So, all right, in this case, you'd say, okay, if I was looking for the 6th term, it's just the 5th term plus the difference. Well, that's always hard. Well, if we're talking about the 29th term, do we always have to go to the 28th term? And then really, how hard would it be to find the 29th term? That's where we kind of look and we say, okay, isn't there some way we can start with the beginning term and go from there? And so that's what we're going to be getting into. So let's talk about this. We could do this actually pretty quickly on a calculator. Let's first look at our values here. -6, -2, +2, and what are we doing each time? Well, my d, or each time, what I'm kind of doing, and I can kind of do this by my head here, I'm adding 4 each time. All right, so really I just need to add 4 each time. So I need to find the 20th term. This is my first term. This is my second term. This is my third term. So we need to find the 19th term and add 4 to it. Well, all right. I think the quickest way to do that, if you don't know any other formula, all right, is to start here with your calculator. I gotta go back and remember. We started with a -6. It's to say, okay, -6 is my first term. And each time we're adding 4. Okay? And so that's first term. That was my second term. My third term, there's my third term. Oh, what did I do? I'm sorry, guys. My third term, oh, I had too many. I'm going to clear it and start again. So we started with -6. I had my second term was -2. My third term is +2. And then the fourth term, now I can just hit enter, is 6. Fifth term, 6th term, 7th term, 8th term, 9th term, 10th term, 11th term, 12th term, 13, 14, 15, 16, 17, 18, 19, 20. You have to be really careful you do it exactly right amount of times. We found for an answer of 70. And I hope you're saying what I'm saying. There's got to be an easier way. All right? And that's what we're going to get at. There's got to be an easier way. Let's talk about our easiest way, an explicit formula term, where a sub n is the term we're looking for. All right, so it could be in the case it was the 20th term. N, all right, a sub n is n, it is the term. It's right. It's kind of like the whole value. All right, the term or the term value. All right, n is like what term it is. Is it the first, the second, the third, the fourth? All right, so n is the position of the term. First, second, third, fourth, fifth. D is the difference. And this, A, is the starting term. What is our beginning term? All right. So in this case, we started at -6. We went up by 4. And we wanted to have 20 terms. Okay. So here, we're going to have our -6 plus 4 times, essentially it's 19. It was 20 minus 1, we could just put in 19. We got our answer. We have the same answer. We had confirmation that our original answer was correct. All right. So, when we have to find an nth term, well actually we're going to look at this in another video.